How's it going, ladies and gentlemen? Mr. Donahue here again, and we're going to take a look at other ways to measure concentration. In the last video, we talked about molarity. We're going to talk about other ways to measure concentration. One being percent by mass, another one being percent by volume, and the last one being ppm, or parts per million. All right, so let's take a look. Formulas for these percent composition equations. Percent by mass is basically just the mass of the solute, which is your part, over the mass of the solution, which is your whole thing, times by 100, just like any other percent. Percent by volume, almost exactly the same thing. Instead of mass, though, they're using volume of solute. So this is your part over volume of solution, that's your whole, times 100. So let's take a look at a sample problem. It says calculate the percent by mass of a solution that contains 35.8 grams of Na2SO4 in 136.3 grams of solution. All right, cool. So that's kind of easy. Percent by mass equals the mass of our part, our solute, 35.8 grams, over the mass of our solution, 136.3 grams, times by 100. That's all you gotta do. What do we get? We get 26.2%. So that's 26.2% of Na2SO4. Not too bad, right? Volume, same thing but different. Calculate percent by volume of a solution that contains 4.55 milliliters of ethylene glycol and 7.83 milliliters of solution. All right, well, again, percent by volume is going to be the volume of our part, 4.55 milliliters, all over the volume of our solution, 7.83 milliliters of solution, times by 100. Well, what do we get then? We get 58.1%. Piece of cake, or pie, whatever you like, not here to judge. And the last one may be new to you guys, parts per million. So parts per million formula is the mass of the solute over the mass of solution, just like what we've seen before. So we got part over a whole. But instead of timesing by 100, we times by a million, or 10 to the 6. So we use this when we have really low concentration stuff. Right? This is like when we're talking about lead in water stuff, because there doesn't need to be a lot of lead for it to be dangerous. Right? It could just be a little bit, little tiny bit, and it's really, really bad for us, especially if it's in our water, because you drink that stuff. So here's an example. A sample of tap water is analyzed to show contained 0.015 grams of lead ions per 10 grams of solution. I want you to calculate the concentration in parts per million of the solution. So parts per million would equal the grams of our part, grams over lead, 0.015, over grams of solution, 10 grams, times by a million. 1 with 6 zeros after it. So we plug and chug, beep, pop, boop, and we get 1,500 parts per million. Now, if you have a stupid calculator that can't handle all those zeros, what you can just do is you go, all right, let me do this part, and I get 0.0015, and then I gotta move the decimal place 6 times because it's a million. So I go 1, 2, 3, 4, 5, 6, and that's where the decimal place would go. So you get 1,500. So if you're using a stupid calculator, that's how you get around it being stupid. You got to be smart. All right, well, I hope you found that helpful. Not that bad, right? And I'll see you in class. Bring questions.